to continue the next session. Over to sir. Thank you.
Thank you, sir. It is my pleasure to introduce our next speaker, Dr. Harish Garg. Dr. Harish Garg, working as an associate professor at Thapar Institute of Engineering and Technology, Patiala, Punjab. He is ranked in the world top 2% scientist list, India rank 1, world rank 163, published by Stanford University in the consecutive 5 years from 2020 to 24 last year. He received the most outstanding researcher award in the field of mathematics from Error 360 Academy. He is also the recipient of International Ovada Prize in 2022 Young Distinguished Researchers. He is also the recipient of top cited paper by an India-based author from 2015 to 19 from Elsevier Publisher. He is also serves as an advisory board member of the Universal Scientific Education and Research Network, namely USERN. He is the research fellow of INTI, International University, Malaysia, adjunct researcher at Asia University, Taiwan, adjunct professor at Sunway University, Malaysia. Dr. Gaur's research interests include computational intelligence, multi-criteria decision making, evolutionary algorithms, reliability analysis, expert systems, and decision support systems, computing with words and soft computing. He has authored more than 540 papers, over 510 are ACI, published in referred international journals including IEEE, Transactions, Elsevier, Springer, etc. His Google citation are over 29,000 with H-index 95. He is one of the leading researchers in the world related to the MCDM and soft computing approaches. Dr. Garg also serves on editorial boards of several leading international journals. This includes the founding editor-in-chief of Journal of Computational and Cognitive Engineering. He is also the associate editor of Alexandria Engineering Journal, Journal of Industrial and Management Optimization, Machine Intelligence Research, CAAI Transaction on Intelligence and Technology, and many more. I can conclude here. So over to Dr. Garg. Please start your presentation. Thank you.
Thank you. Thanks, Sovan. Thanks for introducing me. Let me share my screen. Can anybody confirm that whether my screen is visible?
Yes, it is visible.
Okay. Okay, so thanks once again for inviting me, Madhumagan Pal, and the other organizing members for deliver my talk on aspects of decision-making process. Generally, what I try to cover in this next 40 or 45 minutes is, I just give you the basic idea how you can think about the decision-making process and under what cases you can apply the fuzzy set theory, or under what cases you can apply any of the other extensions of the fuzzy set theory. Sometimes the young researchers might confuse that how we can apply the fuzzy set theory and under what case we can apply the fuzzy set theory. For example, if I say if we toss the coin, then definitely we all know that probability of getting the head is 0.5. But can we say that can we define the fuzzy set theory corresponding to this experiment, tossing the coin? Or if I say somebody is returned from the university Can we say this line involvement of the fuzzyment, and so on. So that's why today's talk is a very general talk related to the decision making process. Now, myself, Dr. Harish Garg, I'm working as an associate professor at Thapar Institute. My research area includes the evolutionary algorithms, decision making process, reliability optimization, and the fuzzy set theory. I'm working as the founding editor-chief of the Journal of Computational and Cognitive Engineering, which is a Scopus Index journal, and the few associate editors of the journal. If you are interested to look about my some works, you can follow or you can download these edited books, which are related to the Pythagorean, reliability, and many more books are available under my umbrella. Now, come back to the major title, that is the aspects. As I mentioned that the term is aspects. How you can think about the aspects of the decision making? The first question obviously arises in every young researcher mind is, what is the decision making process and why there is a need of the decision making process? So first of all, suppose you want to buy the mobile phone. If you want to buy the mobile phone, definitely whenever you want to select the best mobile phone, definitely you have the several options in your mind. You want to select the best battery backup, you want to select the best memory, or you want to minimizing the cost, you want to maximizing the gallery space, and so on. So that means you have the various options. Similarly, if I say if you want to select the best person in your life, like in case of the marriage, or if you want to select the best suitable candidate from the interview, all these are the best examples for making the decisions. Because whenever you want to invest some money or you want to select the person, your target is to make a best decision. So definitely the term best is a linguistic variable, because it is the best for you, but it may not be best for the other people. So my target or the decision making target is how we can choose, how we can make the decisions available easily, or how we can make the decision better and better, so that your product will be more reliable and it will be more consistent. Now, the question arises is how we can address the question number 1 and question number 2. How we can make the decisions stronger, or how you can make the decision better and reliable. So first of all, once we are talking about the classical decision making, so classical decision making involvement of the 3 phases. The first phase is the set of the alternatives. Second is the set of the actions or the target available by the decision makers, and the rest of the third is the expected outcome. For example, say you want to buy the car, fine. Then how many options you have? You may buy the Honda car, fine. You may buy a Tata car, you may buy Maruti Suzuki, and so on. So these are my various alternatives, because your target is to select one of them. Your target is to select one car among these various options. So these are called as the alternatives. Now, the one way is you can select by randomly. That means you can select either as a Tata car for the more reliable, or you can select as a Honda car, and so on. But if you really want to do a decision making process, you have to check how much cost of this Suzuki car, how much reliable this product, or you can say how much reliable in terms of the mileage, or any of the other parameters you can include. Similarly, you can include the Tata for the cost, you can include the mileage, and so on. Similarly for the Honda City. So that means your target is to create the hierarchy related to the alternatives, related to the various action you have taken, and finally the set of the output. Now the question arises is how you can make a decision. So always in our day-to-day life, we can make a decision in the two aspects. The first aspect is we can make the decisions under the condition of the risk. Once we can make the decision with respect to the risk, then we always look for the game theories, or sometimes we call as a probabilistic decision making theory. You may heard about in your optimization techniques courses in your graduate or undergraduate programs that you can use as a game theory, optimism and the pessimism probabilistic theory, or you can call as a Bayes theorem in the probability. So whenever we are talking about the risk, we always look about the game theory to make the decision. On the other hand, whenever we are talking about the vagueness and impreciseness, then we always look about the fuzzy set theory. I will explain you with the help of the examples as well how we can identify that what is the vagueness and how you can identify what is the impreciseness. But before that, I can classify the decision making process. So definitely once we can make the decisions, it is basically on the two aspects. How you can make a decision? You can make a decision based on the single person, or you can make a decision based on the multiple person. Multiple person means you can make a decision based on the group of the experts. Like if you want to select, for example, if you want to select a candidate, if you want to select a candidate for an interview or for an assistant professor, for example, then definitely the vice chancellor or the director of the institute will appoint a committee. So they can expert 1, they can appoint the expert 2 or expert 3. They will evaluate the each candidates based on their qualifications, experience, reputations and the knowledge are there. So in that case, because we have considered the 3 different experts, that is a part of the multiple persons or multiple experts decision making. Or how you can make as a single person, if you want to make a decision by own or by a single person, then you can call as a single person decision making or call as a single objective decision making. But once we can classify as a decision making, all the problems are classified as either as a single or considered as a several decision makers. Definitely, once we can make as a several decision makers, our target is to involvement of the multiple persons to make the decision smoother. And it is quite obvious that once we can involve the multiple experts during the decision making process, the conflictness between them is also increasing. So our target is also to reduce the conflictness, or you can minimizing the conflictness between the different decision makers. Second aspect is, once we can solve the problems, we can involvement of the utility functions, fine. Or why we call as a utility function, our target is to, what is a utility? That is, either you can consider as a profit, you can consider as a cost, you can consider as a reliability. That's on your choice. Any function which you can utilize for making a decision. Or you can make as a multi objective optimization problem, MOOP, multi objective optimization problems under the several constraints. Fine. The constraints may be of the human features, maybe of the space, maybe of the volumes, and so on. So all these factors are involvement of the multiple objective criteria. For example, if you want to say you can maximize the F1 and you can minimize the F2. So that is my multi-objective optimization problem. But whenever we are talking about the individual decision maker, that means a single expert will evaluate each of the possible outcomes, their goals, as well as their constraints. So any decision making is always set up of the 3 features. The phase 1 is we can set up the actions, what you really want to do, set up of your desired goals, and then you can set up the constraints. And your target is to optimize your decision. You can optimize your decision based on these 3 aspects of the decision making model, and your target is to make them as a reliable. On the other hand, Once we are talking about the multiple decision makings, definitely the same set is evaluated by the expert 1, by the expert 2, and so on. So each of the expert has evaluated each goal. They can check each of the constraints, each of the actions, and then make the decision by own. The expert knowledge from the various person is utilized to make the decision. That means whatever, say for example, this is decision 1, they can make a decision 1. It may possible that it can make the decision 2, which is entirely different from the expert 1. So in that case, we try to minimizing their conflicts, or we can try to compromise their solutions to make a common solution, which I call as a D star. D star is the common solution that agree by the expert 1, agree by the expert 2. But once we are talking about the basic difference between the single decision expert as well as the multi-person experts. So first of all, the goal or whatever the target you can say, they are differ to each other, because each expert, as I mentioned you, each expert have their own targets, have their own goals, have their own constraints to evaluate the candidates or the possible alternatives. So that's why each expert or each target is different and have their different arrangement. Arrangement in the sense, the first experts, if you have say A1, A2 and A3, these are your alternatives. Fine. And if I say expert 1 will evaluate these 3 alternatives, then it may possible that the expert will be selected by A2, while the expert E2 will evaluate A3 as the best candidate. Second thing is, whenever we are talking about the multi-person decision making, always the decision maker have assessed the different informations based on their decision. What is the meaning of that? Because each expert have their own knowledge, have their own expertise, have their own limitations. They may think that he or she is the best one. The second expert may think based on their experience or judgment that he or she is the best one. So that's the basic difference. There is a conflictness between the single to the multi-person. So in general, whenever we are talking about any decision making, whether it's a classical or it is in journal decision making, we always involvement of the 3-step procedure. We can define the alternatives, we can evaluate the alternatives, and then finally we can compare the alternatives. For example, if I use the same example, you can pick the car. You have the different choices: Honda City, Tata car, Maruti Suzuki, and so on. So these are my set of the alternatives. Then the expert will evaluate the Honda car based on the different parameters, like the parameter is say my safety, the reliability, the cost, or you can say the mileage. Fine. So for example, if I say the expert 1 will evaluate the Honda City car based on the safety, so he will give on the scale of the 10, he will give say 7 marks, while he gave 8 marks on the Tata car, while for the Suzuki models they gave as say 7 again. Similarly, in case of the reliability, he gave 9 marks for the Honda City, 7 marks for the Tata car, 6 marks for the Suzuki. He gave 6 marks for the cost with respect to the Honda, 5 marks with respect to the Tata car, and 8 marks for the Suzuki. And similarly for the mileage, you can say this is a 9, this is 8 and 9. Fine. So this is the evaluation of the alternative. Each alternative is evaluated by the single expert. Now, once you have evaluated them, can you find the best one? Which one you can pick based on these ratings? So clearly say your target is to minimizing the cost, your target is to maximizing the mileage, Your target is to maximizing the reliability as well as safety. So clearly say this is a conflicting nature. Once one objective is your minimizations, other is your maximization. So your target is to find the compromise solution. Fine. So once you can solve, there are the several methods, aggregation operators, AHP, and many more are there. Once you can solve by either of the methods, you may use as a top saves. Fine. You may use as a AHP, and many more are there. So based on that, you can compare the different alternatives and select the best alternative. Anyhow, once we have seen in this example, we have some problem is of the maximizations, few are in terms of the minimizations. Then we can define the multi-criteria decision making as maximize or minimize some objectives. The FIs are my objectives. The G are called as the goal, or goal is also known as your constraints. Fine. And these are X is my lower and upper bound. So these are called as the bounds on the decision variable. So if you want to maximize or minimizing the cost or the profit, you have the target of, like if I say your target is to maximizing the profit, your target is to minimizing the cost. So this is the multi-objective. This is my F1. This is my F2. Then what is your constraint? So constraint will be your space. Constraint may be your volume. Fine. Constraint may be your manpowers, and so on. So these are my constraints, G1, G2, and G3. These are my constraints. And sometimes you may need the space to be less, volume to be more, manpower to be less, and so on. So all these are my constraints subjected to the bounds of the, if I say objective function is dependent on the variable X, objective function 2 is dependent on the Y, then we can say the lower bound of the X, upper bound of the X, lower bound of the Y variable, and upper bound of the Y variable. So once you can form this multi-criteria decision making based on this phenomena, I can discretize this MCDM into the two aspects. One is called as the MADM, which is abbreviated as the multiple attribute decision making. Second is known as multiple objective decision making. There is a big difference between them. MODM and MADM. There is a big difference between them. What is the basic difference between them? You can see whenever we are talking about the multiple objectives, in this case, there are several objectives. When there are several objectives are realized to make a decision, then we call as the decision making is multiple objectives. Once we can talk about the MADM, in that case, you can see the word is realized and it is carried out. There is a big difference between these two words. I will explain you the example as well. So whenever you want to evaluate the alternatives based on the several attributes, then we call as the MADM. Mostly this problem is called as a discrete problem. Fine. And this problem is called as a continuous problem. But that is not always. It may possible that it is a discrete as well. Fine. The basic difference between the MADM and the MODM is, whenever we are talking about the criteria, in a MADM we have an attributes, while in the MODM multiple objectives we have the objective function. In this case, our goal, our target is the implicit, while in case of the MODM is my explicit. Like the same example, if you want to pick the car, again I can pick the same three alternatives. Fine. Now you can see what is your goal. What is your goal? Your goal is to pick the best model car. Fine. Your target is to pick the best model car. That means your goal is my implicit in nature. So once this is my implicit nature, the decision making process, involvement in the selection of the car is MADM. Fine. Again, in this case, the attributes. What are the attributes? You can say the attributes are my mileage, attributes are my cost, fine attributes are my reliability, all are my explicit in nature. While in case of the MODM, they are my implicit nature. The constraints are my inherents, and they're definitely, when you can talk about the multiple objective, your constraints are the G1, G2, and so on. They are always expressed in the mathematical form. Once we can talk about the alternatives, you can see there are the A1, A2, and A3. So there are the three alternatives which are the finite in nature. And the usage is your target is to evaluate, or your target is to select the best car. You can see I can pick. Pick means you can select the best model car. So that's again defined for the MADM. While for the multiple objectives, our target is to design the model, and your target is to find the best solution which has a less error. Now, you can see that in a MADM we have the problem which we assume to be predetermined. Like in this case, our target is to select the best model among the given models of the car, and it has a limiting number of the alternatives. On the other hand, once we are talking about the MODM, our alternatives are not given. You may have maximization of F1, F2, and so on, or you can have a minimization of G1, G2, and so on. And their constraints are explicitly defined. It may possible that the number of the decision alternatives, that is F1, F2, it may be the up to the 50, or it may be to the 100. So in that case, whenever you have the large number of the alternatives, to select the best one, you always apply the MODM problem. Now once we can model, once we can understand that under what cases we can apply the MADM, under what case we can apply the MODM. So now, during the modeling of the any decision making, we always consider the three aspects. The first one is how we can deal with the vagueness or ambiguity, because as I mentioned you, there is always a conflict of interest between the different experts, between the different alternatives, or as well as the goals. So how you can balance the vagueness, or how you can handle the information. This is basically, you can say, how you can handle the informations during your decision making process. The first question arises here. Second question arises is how you can evaluate the information. Once we all know we have these three different cars. I use the same examples so that you can understand it till the last. How you can evaluate the Tata car with respect to the any parameter, say mileage, say reliability. How you can evaluate the information, because your target is to evaluate the information based on the human thinking, not based on your logbook. Not you can take the data from the industry. If you want to express how you can express the human thinking, because different person have the different thinking, so definitely they have the conflict. So once there is a conflict, then the question arises is again how you can deal with that. And the last case is once you have the different expert, say expert 1, expert 2, expert 3, and if you are evaluating the parameters based on the mileage, based on the cost, based on the reliability, and so on, definitely for example, for me the reliability of the any product is much more important than of the cost. So I will give the more importance on the reliability, then on the cost, and then on the mileage. While for the other persons, it may possible that for them they have the more importance on the cost, second importance on the reliability, third importance on the mileage. That means the different people have the different weightage factor. They have different weightage factor. Similarly, for the experts, if I say this is my vice chancellor of the university, this is some senior professor of the university, and this is say any professor of the university. So for the different peoples, the vice chancellor has the priority 1, senior professor has the priority 2, and then it's a 3. While for some other purpose, say this professor is a highly renowned one, then we can assign as a priority 1 and stop. So the third objective is how we can define or determine the weights as well as the alternative weights. So these three process is challenges in our decision making process. So young researchers are always worried how we can select the MCDM problem or the MADM problem. The first question is, whenever we are involvement of the uncertainty or whenever we are dealing with the weakness, our target is to use the fuzzy set cube. Always remember, fuzzy set or fuzzy logic is always deal with the ambiguity and the vagueness. As I promised you in the starting of the video, the starting of the lecture, what is the vagueness and what is the ambiguity? How you can differentiate between them? What is the difference between them? There is a big difference between them. So firstly, I will tell you what is the vagueness. Fine. Remember students, once we can solve the MCDM problem of any case, whether it's an industry problem, whether it's a day-to-day life problem, your target is to analyze whether you can use the ambiguity procedure or the vagueness. For example, what is the vagueness? The vagueness is whenever, first of all, it's uncertainty, definitely. Whenever you are unable to make a difference between the two classes. Fine. For example, if I say this teacher, this is the question, I am a tall. The person standing in the middle of your screen, they are asking that whether I am a tall. The person on the left of the screen, that is the person, he is a he said no, he is not a taller. Why? Because you can see the height of this person is taller than of the middle one. While once you can consider this girl, then he said yes, the person which is standing in the middle is a taller. Why? Because the girl is a shorter height than of the person. So what does it mean? Is I am a taller? According to him, the answer is no. According to her, answer is yes. That means you are unable to clearly differentiate between the two different classes. What are the classes? The class is one person which are taller than of the middle one. Second class is those people whose height is shorter than of the middle one. So that means you are unable to classify, you are unable to differentiate between whether this is a taller or not. Fine. On the other hand, if I say the person height is up to this, then definitely your answer is yes. Then in that case you are able to differentiate between them. Then there is no uncertainty, then there is no vagueness, and then there is no use of the fuzzy set theory. So once we are able to once we are unable to make a decision, then we always use the concept of the fuzzy logic, or we can call as the subjective logic instead of the objective. Second case, what is the ambiguity? Ambiguity means once we are unclear meanings and the interpretation. For example, if I ask you whether the line he returns from the bank is the clear statement, if I say is it a clear statement or what do you think about this line? What do you think about this line? He returned from the bank. What do you think about this line? So if you think that this is a clear statement, then definitely your answer is wrong. Why? If you look about this very carefully, what does the meaning of the bank? What is the meaning of the bank? Is it financial bank? It may or may not be. It may be the side of the river. We all know the side of the river is also known as the bank. Fine. Or it may be possible any of the financial institute. Fine. Or any of the other terms which you can correlate with the bank. So what does it mean? That means this line he returned from the bank has unclear meaning and it has unclear interpretation, because for me it is the side of the river, while for you it is some financial institute. That means this line is unclear meaning. So that means this line is involvement of the ambiguity. So once this is the involvement of the ambiguity, we can use the fuzzy set theory to deal with the problem. On the other hand, if I say the person tosses the coin, fine, the person tosses the coin, does it have an unclear meaning? No, everybody knows that tossing the coin has the same meaning. So that means there is no ambiguity, there is no ambiguity, there is no vagueness. So that means we can never apply the fuzzy set theory on this problem. Yes, you can apply the fuzzy set theory to tossing the coin, provided you can complete this line by the few more words, and that word will define for the vagueness and the ambiguity. Anyhow, so once we can talk about the ambiguity, you can see ambiguity has an unclear meaning. Can you think about any of the other example which correlate with the ambiguity? That is a multiple experts. For example, say this is a one object, this is the one object, fine, and this is the one person, this is the second expert, this is the third expert, and this is the fourth expert. This is my experts, fine. They look about the objects. What do you think about the expert one? They may think that it is a one box. They may think that it is some rectangular box or rectangular plate. They can think about, say, plate, or they can think about, say, this is a any of the pizza type of the product. So that means the ambiguity always arises when you have the multiple experts or when you have the observers which has the different interpretation. Very famous example is, suppose you go to the interview for the selection of some research positions, teaching positions. What will happen with you? Different people, different experts will try to evaluate you. That means you are here, say this is you, these are the various experts, they try to evaluate you. Definitely these people, this expert has the different opinions about you. This expert has a different opinion about your words, about your statements, about yourself. Similarly, these people has a different experts or opinion about yourself. So that means whenever you have the multiple experts or the multiple observers, always ambiguity arises. Other examples you can see in these various cases. Fine. Now, another challenges which we are dealing with the decision-making processes, how we can determine the attributes weight. That's the most important feature. There are the three kinds of the approaches you can apply to what is the meaning of the attribute weights. As I mentioned you have the different goals, say goal 1, goal 2, goal 3 and goal 4. So what is the priority of the goal 1? What is the priority of the goal 2? Priority of the goal 3. If I say the goal 2 has the priority 1, goal 1 has the priority 2, 3 and 4. So these are my priorities, that is my choices. So how you can make as the weight? So definitely if they have more weightage, so I can give as a 30% weight to the second goal. Second is my third, I can put as a 25% weightage, 20% weightage for the first, and the remaining one is for the last one. Now, how you can determine the weight in your procedures? So you can make the determination by the three procedures. One you can make as a subjective, objective, or you can combine them. You can hybrid the weight by using the subjective and the objective. All these informations are based on the expert's opinion. What is the objective information? Once you can talk about the objective weight determination methods. So what is the subjective weights? They are usually taken by the experts based on the brainstorming, based on the discussions, or based on the questioning array. So once the expert will discuss with you in terms of the discussions, in terms of the question array, they can evaluate you and then they can subjective the weighting. This is mostly happen in your selection procedure interview. On the other hand, whenever such kind of the preferences like brainstorming, discussions, or the questioning array is not available, then that means you have the lack of the knowledge or lack of the information. Once you have the lack of the information, that means the subjective weightage method is not applicable. Once these methods are not applicable, then we can apply for the objective weight methods. What is objective weight methods? That means whatever the data, or you can say the information you have collected, whatever the information you have collected related to the alternative. Fine. Say I collect the information x1, x2, x3. Fine. You can collect the information, say x1, x2, x3. You can define the weights based on these xi's. You can define the weights based on the x1, x2, and x3. That information is called as objective weight information. Why? Because this x1 is the data which are provided by the expert during the evaluations of the alternatives. Once it's evaluated by the expert, you can assign the weight based on their judgment. Now, once you have the different set of the attribute weights, you have the different set of the solutions. In that case, you have to target to find the most efficient solution. If you remember that in your multiple objective, we always call as the Pareto optimal solutions. That is similar to the MODM, multiple objective decision making. While in case of the MADM, multiple attributes, we are called as the most efficient solution. Now, how you can solve the problem? There are several methods. I'm not going to the detail, because otherwise if I try to explain each of the part, then it will take around 1 hour again. But anyhow, I will tell you the different methods. You can scroll down from the literatures or the standard books. Various methods you can use for solving the decision making process. First one is the SO, that is a simple additive weightage. As the method suggested you, it's a weightage. Once, as I mentioned you, say this is your alternative 1, this is alternative 2, this is alternative 3. You have the goal 1, goal 2, and goal 3. If you give the weightage as A, B, C, D, E, F, G, H, I. What is the A, B, C, D? These are the expert information. Fine. Now, what is the meaning of the simple additive is? Your target is to weightage. I can take the 30% weightage to the A1, or if you want to weight, say 40%, 20%, and 40%. Then you can find the weightage corresponding to alternative A1. This is a 40 into A, that is a 0.4 into A, plus 20 into D, 0.2 into D, plus 40 into G, 0.4 G. This is the value corresponding to the alternative A1. Similarly, corresponding to the second column, you can find the values which is defined as 0.4 B, 0.2 E, and 0.4 H. These are value corresponding to the A2. Similarly, you can find the value for the A3. Based on your target, whether you want to maximize the problem or minimizing the problem. If your target is to maximize them, then pick the value. Whatever the answer you have obtained corresponds to the first case, second, and the third case. Which one is a bigger one? That will give you the best decision related to the SAW method, simple additive weight. Similarly, once we are talking about the Topsis method, you can find that similarity between the different alternatives and then find the ideal solution. AHP is one of the most popular techniques, that is for the analytical hierarchy process, and another one is the electric procedure. Apart from these methods, there are several other approaches for solving the MCDM problems, say aggregation operators, distance measures, or you can say any of the information measures. That information measure may involve the entropy or any of the other parameters. You can apply the probability theories called as the correlation coefficients, divergence measures, all are related to the probabilistic theories. And definitely you can apply the non-linear optimization problems by formulating as the non-linear problems and solve by either of the methods like any of the soft computing approaches or meta-heuristic like PSO, genetic algorithms, and many more approaches. Another approaches apart from these are you can formulate an optimization problem corresponding to your goals, whether it's a maximization or minimizations. You can apply the entropy measure as well. It's a very well Shannon entropy. You can read the literature related to the Shannon entropy. It's a very, very famous measures which are very reliable for solving the problems. If I call as E is my entropy corresponding to the variable X, then I call as a minus of the X ln of X. This is a very famous entropy measure. You can study their properties, very famous for the physics point of view as well. You can formulate the multi-objective optimization problems as well. So not on these three approaches are there are several other methods as well. You can formulate any of the other measures. You can apply the hybrid approaches. Hybrid approaches means you can formulate an optimization problem. You can combine the correlation problems, correlation coefficients into the optimization models, and then you can apply the AHP to make the decision process smooth. So this is all about the basic techniques, basic idea how you can think about MCDM problem in your day-to-day life. So I hope you can go through the literatures and try to explore more for your research purpose. So thank you very much. If you have any doubt, you can let's go.
Audience, if any question, please unmute and ask. Professor Dubey, will you ask any question?
Yeah, Professor Garg, my name is Vivek Dubey. I have a background in management, and that's why I'm keen on this MCDM techniques, and also I have some background in operations research. So because of that, I have been trying to do some work with fuzzy sets and other things, and I do work with Professor Sowan. So the final thing that you mentioned, that there is a way to combine these. So we have been working on some paper on that topic. Maybe outside the forum, I would like to engage. How do you actually combine these methods? Because just AHP and all that does not appear satisfactory to me. So I think I will connect later on that topic. I have to be outside. So thank you so much for your presentation.
Sure, most welcome. Thank you.
So any question from any other audience? So I have one question actually, how to control the biasness of experts. Means, is there any kind of technology or fuzzy technology can be applied? So what is your suggestion?
We can control the biasness of the experts. The better thing is we can use the linguistic variable. That is more reliable than of the quantitative information, because in that case we are not providing the particular numbers, we are providing in terms of the range. So that is, we can try a little bit improve the biasness in the experts' decision.
Okay,
so just one comment. We do some work with survey-based data and qualitative data. So these problems keep appearing, and there are techniques that I have used in survey-based data combining with statistics. So I was curious to know how can we combine these, especially see entropy and other things. We have been using with one of the students. But I think a better method can evolve if we combine these techniques, because I think there are all specialized ways of handling information. But the big question is, how do you truly answer criteria? How do you actually make a decision when you are mentioning some of the objectives can also be constraints? So I think we may be able to solve some optimization problem based on techniques like this, not just constraints, but using some of the objectives as constraints also. So those are some of the thoughts, but we can discuss later. Thank you.
Yeah, sure.
So I have one more question from Dr. Prosenjit Mondal, and he asked, without consensus reaching process, is decision outcome acceptable?
Without?
Consensus reaching process, group agreement.
Okay. Yes, it is possible, but in that case, it might be possible that some unbiased alternative may came into the picture. So to remove that unbiased or the non-reliable, non-efficient solutions, we always use the consensus argument. Otherwise, because the Pareto optimal solutions or the efficient solutions are so many, our target is to pick the best one among them. So for that case, we are using this indexing.
Okay, one last question from me. Actually, we are using ChatGPT and we are asking any kind of doubts and asking the decisions. So they may be prepared with some technology. So as an expert, will you suggest to accept their decisions? Though it is a philosophical question, but you can answer on this. The decision made by artificial intelligence acceptable or not? Or how many percentage, for example, ChatGPT?
ChatGPT is not so much reliable because the error rate is so much. So once if you collect the information from the ChatGPT, so first of all, it is based on the historical information. That is the information they have collected based on the subjective, not as objective. Once you can convert into the subjective to the realistic objective information, you can't predict the future based on their past information because they are not accurately trending the homogeneity. They are heterogeneous actually. That's
okay. Thank you very much. Any more questions, or I should conclude? Thank you, Professor, for your nice presentation. It is helpful for all beginners and experts also.
thank you.
Over to Dr. Pal for the next announcement.